In this video, we are going to do a harder probability density function, or PDF, example. So the example says that 5 seniors, 3 juniors, 2 sophomores, and 2 freshmen are racing. There are no ties, and it is known the freshman will finish in the last 2. Let X be the lowest a senior finishes. So for example, if X equals 12, that means that a senior finishes last, because if we count the total number of people, 5 plus 3 plus 2 plus 2, there are 12 total runners. So if X equals 12, we'd be saying that a senior finishes in that 12th position, which would be last. Okay, so the question then says, well, find the probability that X equals 8. So I want to begin by giving you the opportunity to try this one. So pause the video for about 5 minutes to try this question. If you're absolutely stuck on how to begin after about 2 minutes, unpause it and then watch me begin, and I'll prompt you again to try it one more time. So overall though, pause it for 5 minutes, but if you do get stuck, absolutely stuck for the first 2, unpause and then check back in. 4, 3, 2, 1, and pause it. Alrighty, so hopefully you paused it. If you were absolutely stuck, hopefully you just paused it for 2 minutes. Let's talk about it a little bit together and how we begin. Alright, so we want the probability that X equals 8, our random variable equals 8. So what does this mean in this context? I know probability is going to be a fraction. I'm going to write a big fraction bar so I can write a bunch of words. So on the bottom, I need to count the total number of outcomes, which in this scenario is the total number of finishes, total number of ways that we could order these runners. And on the top, I need to count the number of successful outcomes, which in this case is if X equals 8. So that means the lowest a senior finishes would be 8th. So the top is going to be the number of ways for the lowest senior to be 8th. So if you just paused it for 2 minutes and we're completely stuck, at this point, pause it one more time for another 3 to see if you can work on the denominator or the numerator and make some progress with counting those. 4, 3, 2, 1, pause it. But hopefully after this pause, you'll have paused for a total of 5 minutes to try this one. Alrighty, so hopefully you've paused it and tried it for about 5 minutes or so. It's okay if you didn't finish. I mostly care about, are you thinking about the key ideas and how to begin, and what are the different things that we consider when we compute this numerator and this denominator. So let's focus on the denominator first, the total number of finishes, because that is simpler. Okay, so let's think about this in terms of strategy. So I think there's 2 things that we have to consider. One of the things is the problem says that the 2 freshmen, have to finish in the last 2. So let's first place the freshman in, let's write that better, place the freshman, it should just be 1C, place the freshman in the last 2 spots. And when we do this, the order matters here. The order in which these runners finish matters. So we should not be using combinations. Instead, the way I can think about this is to imagine I have 2 slots, the last 2 slots that the freshmen are going to occupy. And in this spot, if I think about this one first, this should be the number of ways to pick a freshman here to go in that spot, which is 2. There's 2 choices for what freshman could go there. And once we pick them, there's 1 choice for what freshman goes in that last spot. Okay, so I'm going to leave it like that, but I could multiply if we wanted to. We would get 2 if we multiplied it. Let's think about the next thing in the strategy. Once we've placed those freshmen, now let's place the remaining people. And there's going to be 10 people remaining because there were 12 people overall. And again, the order in which we place them, let's write this in red. The order in which we place them matters. So we're placing them in the 10 remaining spots. So in the same sort of way, there's going to be 10 choices for who goes in that first spot, times 9 for who goes in that second spot, times 8 for who goes in the next one. And I keep going down like this until I've placed all of these people. So we'd get until we get 2 times 1, which is 10 factorial. There's going to be 10 factorial ways for the second part of this. So overall, for counting the total number of finishes, we get 2 times 1 times 10 factorial. So that is our denominator. Total number of finishes is this. We are ready for the numerator now. All right, so now let's focus on the number of ways for the lowest senior to be 8th. So just to get a feel for this, I'm going to start it off by drawing some spots or some slots for these positions. So 1, 2, try them a little bit smaller. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's zoom it out a little bit so I can see these more. That's 9, 10, 11, 12. So here's 1, 2, 3, 4, 5, 6, 7, 8. So here is spot number 8. And for that spot, it's got to be one of the seniors. So there are five seniors here. So there are, oh, there we go, 5 choices for the senior to go here. So 5 choices there. So if I think about this in terms of strategy, let's first place a senior in that 8th spot. So we just said that there's 5 ways to pick which of those seniors goes there. 5 ways to pick one of the 5 seniors here. Okay, and then after that, now let's place the other seniors. Let's place the other seniors. And how many are there? Let's see, there's 4 of them. Place the other 4 seniors in, well, the lowest senior is in the 8th spot. So that means these other 4 have to be in the first 7 somewhere. So the other 4 seniors are in the first 7 spots somewhere. And the order in which we place them matters. Order matters. So for the first one of those seniors, there's going to be 7 spots that we can put them in, any of these first 7. And then once we place that first senior, like if they go here, now there's 6 choices left for the next senior and where they can go. So hypothetically, if we put them somewhere here, now there's 5 spots left where we can put the next senior. And if I kept going like this, there'd be 4 choices left for where to put that last senior. And I'm going to leave it like this just so that, because when we finally write down our probability as a fraction, a bunch of stuff will cancel, and it'll be easier to see if I leave it like this for the time being. Okay, so I've dealt with the seniors. The other piece of information that I was given specifically was about the freshmen. So let's place them. Let's place the freshmen. And they go in the last 2 spots. And we already saw how to handle this when we counted the denominator. This was 2 times 1. 2 times 1 ways. Okay, and then finally we got to place the remaining people. So the 4th step to the strategy is now we place the remaining, let's see, there were 12 total people. and there were 5 people in steps 1 and 2, and there were 2 people here, which means to get to 12 total, there have to be 5 people left. So we are going to place the remaining 5 people in. At this point, there are 5 remaining spots. In the 5 remaining spots, so these are the juniors and the sophomores, and there's no restriction on where they can go. So there's going to be 5 choices for the first, which spot to put the first person in, and 4 choices for the next one, and 3, and then 2, and then 1, which is 5 factorial. 5 factorial ways to place them. Okay, so we are ready to put this all together and write down the probability that x equals 8. Okay, so if we do that, or actually, you know what, let's write down the denominator first. So let me move this on down. Let's write the denominator first. So let me zoom it out. Remember, the denominator was this whole thing here. So if we put all of these numbers together, we will get, so there were 5 ways for that first step, and then it's going to be times 7 times 6 times 5 times 4, and then it's times 2 times 1, and then finally it's times 5 factorial. Let me highlight this as well. So highlighting this and highlighting this, and let me go back to the previous page and highlight this numerator. We now know the number of ways to do the numerator. All right, so we are ready to write down this probability. All right, so the numerator is 5 times 7 times 6 times 5 times 4, and then it's times 2 times 1, finally times 5 factorial. And the denominator was 2 times 1 times 10 factorial. Okay, so a bunch of stuff is going to cancel. The 2 times 1 cancels with that 2 times 1. And then the 5 factorial is going to cancel with a bunch of the terms in the 10 factorial. What will be left over from the 10 factorial is the 10 times the 9 times the 8 times the 7 times the 6. And then from the 5 factorial, that's just gone completely. And now if we look at this, I can say that the 7 and the 6, we can cancel those out with this 7 and this 6. And then with the 4 and the 8, we can cancel those a little bit. I'll be left with the 1 here, and be left with the 2 down there. The 5 and the 10, it can cancel a little bit. I'll be left with the 1 here and a 2 down there. And that is it. So overall, we actually didn't need a calculator for this at all, which is nice. So on the top, we just have 5. On the bottom, we're left with 2 times 9 times 2, which is 36. And that is my probability. Alrighty, so in terms of our goals for this section, we finished our last goal, which was to get a feel for random variables and probability density functions by working out more examples.